Hi folks, welcome to another episode of NYC CNC and the Wednesday Widget. Today, let's talk about Arduinos and motors. Arduinos are awesome. I love them. And the reason I got into them whenever they came out, I think it was like 2006, is to control motors. That to me is the coolest thing, taking input from something and an output to something else. And I've done a lot of work with Arduinos and motors, and I've even published two other videos that you can see here below that were pretty popular. One on was controlling big stepper motors, and then the other one was on controlling smaller motors lots of different ways with relays and transistors and so forth. Today though, let's talk about big DC gear motors. These are brushed motors. These have a huge amount of power. They're pretty inexpensive. They're actually incredibly easy to control with an Arduino. We just need to use an external driver. And today I want to walk you through a driver that I really like, and it's really powerful, and it's going to be a lot of fun. This episode is also going to be sort of a framework start for some projects I've got coming up where I want to use Arduinos and these big motors to hopefully do some pretty cool stuff here in the shop. So, without further ado, I thought I'd do the typical NYC CNC walkthrough here. We'll take a look at the hardware, we'll take a look at the pin layout and the wiring of it, and then we'll take a look at the Arduino code. I'm going to show two different examples. One is going to be a simple example. It shows you just how little code you need. So if you're intimidated by Arduino or if you're new to Arduino, you're going to see this is really basic. Then what I'm going to do is we're going to hook up a couple of potentiometers and a couple of sensors, and we're going to have this motor rotate back and forth with a little hammer machine, mostly just for fun, but again to show the control and the speed and the capabilities of this. So what do we have here for today's project? First off, we've got a 12-volt benchtop power supply. You can use a 12-volt battery, like a lead acid or gel cell type battery is fine, whatever needs to suit the motor you're working with. I have this benchtop supply for this use because it's a 50 amp output and we're running this with a big motor and I need that kind of power. We've got an Arduino Uno, we've got a breadboard with some potentiometers on it, and then here is our driver. This is made by Dimension Engineering and it's their SyRen model 50, so it controls up to 50 amps. All of this information, like always folks, is going to be available right here on the Wednesday widget. I'll have a parts list, I'll have the Arduino code, I'll post a photograph of the layout so you can take a closer look, and all that good stuff. The motor we're controlling today is this guy right here. It is powerful. Got it from Surplus Center, and their specs state it's over horsepower, 900 watts, something like 1900 inch-pounds. That's a lot of torque, folks. And it's a standard DC brushed gear motor, so with 12 volts hooked up, you could control it by just an on-off switch. And you could even control it with an Arduino and like a beefcake relay, which I've posted other videos on. Very easy to do, but that's not the kind of control that I want to focus on today. And it's also one reason why these kind of controls are awesome, because as you're going to see here, we've got much greater levels of precision, fail-safes, safeties, braking, etc. So let's dive in. There are two reasons I love these controllers from Dimension Engineering. One, they're just so darn easy to use with Arduino, in my opinion, and again, I'll show you the code here in a minute. The other reason is they're actually pretty affordable. The one I'm using controls 50 amps, it's $120. You don't need such a large motor. They have a $50 driver that will control up to 10 amps, and I think that's continuous, peak of 15 amps for a few seconds. So again, you get the same functionality, and in fact the same code will work with this 10 amp version. There's a lot more information out there. They talk about, even on their product webpage here, you can see the 4 different main control modes are analog, radio controller RC, and then there's 2 different serial control modes. We're going to actually work on one of those serial modes because I think it's a really cool way to work with them because of the level of precision and the nature of how you're controlling it. But again, these controllers are great. When you read down on the product specs on the one we're using today, you can use combat robots, very heavy traditional type robots. You can use these things for scooters and vehicles that need to be controlling a lot of weight. Anything like that with brushed DC motors. So pretty darn cool, and I think that's what a lot of folks out there with Arduinos are looking to do. One of the reasons I make these videos is hopefully to make it easier for you guys to get your projects going. And one of the things that I think is frustrating, if you look at the flyer that they include, they mentioned that the control scale is 0 up to 255. So 0 is full reverse, 255 is full forward, and then right in the middle, 128 is stopped. Unfortunately, and it's kind of frustrating to me, that's wrong. The way these things are actually programmed is instead of being 0 to 255, they're negative 127 to positive 127, with 0 being stop. It's a simple fix, but you could spin your wheels for a while if you're trying to figure out how to make one of these things work. The dip switches also are not complicated, but for some of you folks out there that aren't interested in becoming experts on the driver, but rather want them to just get to work, hopefully this video is helpful. So, again, like I said, information available here on the NYC CNC website. Here is the motor we're using from Surplus Center. You can see the specs here. 40 RPM at the output shaft, 12 volts, and amps ranges depend on how much power you draw, but over a horsepower, about 1900 inch-pounds. But again, it's a lot of power, and we want to control that with the Arduino. So let's go take a look at this really simple example. So you do need the library for the sirens, and again, go to the NYCUC website for the links. We're going to set up a siren. We're going to call it ST. And we're going to start it at serial of 9600, and this matters on the siren on the dip switches. And if you look on the product's webpage, they have a dip switch wizard, and if you go through it, and actually I'll just walk through it with you. So we are using not using the lithium batteries, so we'll click this one. We're going to control it with serial, not analog or RC, and we're going to do the simplified mode, and we're only controlling one. So here we go. This has the different baud rates. We're doing 9600. So if you look closely at the little dip switches, we've got them on, off, on, off, on. Perfect. So back to the code. When we start it, what we do is we do st.motor. 1 means we're identifying the first control board. So you'll never need to change 1, especially if you're only using one siren or one motor. And 0, which 0 again is for stop. So in our Arduino loop in this simple example, what we're going to do is say, again, the same thing, 0 for stop, delay 2000 milliseconds, 2 seconds, and then we'll say go 60. So remember, well, I'll make a comment here, negative 127 is full reverse, 0 is stop, and then 127, I'll put positive in front of it, is full forward. So 60 should be about half speed forward. Continue running that half speed forward for about 2 seconds, stop it, pause 2 seconds, and then go backward about half speed. So let's upload that code and see what she looks like. Okay, you see how easy that is. Let's change the speed. Let's increase the speed one way, decrease it the other, and decrease the delays just so you can quickly see the difference and how we can control it. You should also take a look. What's really cool is these things can break and stop on a dime and reverse and so forth. Okay, real quick, one last simple code. We'll just accelerate everything a little so you can see the speed at which it can start, stop, reverse, accelerate, etc. So how do you hook this stuff up? Well, I've got a lot of wires here. That's actually only because of the footage I'm about to show you, which is using this thing with the potentiometers and some external proximity sensors. All that you need to do for what we just took a look at was connect pin S1 on the siren over to Arduino digital pin 1, which is the TX pin. Pretty darn simple. Over here on the left side of the siren, the outside 2 pins are your motor leads. They call them M1 and M2, but that's not for motor 1 and motor 2, it's just the 2 leads of one motor. And then the inside 2 are your power source for your motor. They talk about using batteries. In this instance, I've got the power supply. It is very important that you don't mix those up, but they're labeled B minus and B plus, minus being your negative, plus being the positive, so hard to screw that up in my opinion. Now let's take a look at what I really want to do, which is using this with the Arduino and sensors and being able to adjust the speed on the fly. So I machined this little hammer on the Tormach PCNC mill. You can see a quick shot of the footage here. mostly just for fun, no real practical purpose other than demonstrating the video. But what I've got is 2 proximity sensors mounted on this strip here. I love these sensors. They're not the cheapest sensors out there. They are, you know, somewhere between $10 and $20 or even $25, but they have a incredibly, they're very well made. They're sealed, they're weatherproof or waterproof, and they're non-contact, so you can detect a signal in front of it without actually contact. So some applications, it's great to have a non-contact sensor. So what we'll do is we'll just throw our little hammer on here. All the code is going to do is alternate this hammer back and forth between the 2 sensors, pivoting, and we'll be able to use the 2 potentiometers to adjust the speed in each direction. So let's take a quick look at the wiring. Again, we've got the SyRen hooked up via this yellow cable to Arduino digital pin 1. Digital pins 2 and 3 are the proximity sensors over here to the side. Those sensors are also hooked to ground via this blue cable, and they take 12 volts. So I've got a yellow wire here that's connected via this red wire back to the 12 volt power supply for the motors that's also helping feed those sensors, because otherwise we've only got 5 volts on this board. Other than that, all you've got is the 1 switch here and then 2 potentiometers. The switch is pulled high with a 10K, and when you push it in, it goes over to digital pin 7 on the Arduino, and then the potentiometers are analog outputs, so they're connected to analog 1 and 2. Again, one side of the potentiometer is connected to ground, the other side is to 5 volts, and then the middle pin is your analog signal pin. It's just that simple. We're obviously establishing a ground and a 5 volt on the breadboard rail from the Arduino, and that's actually it, folks. Pretty darn simple. So let's take a look at this code. Again, it's available to download on the NYC CNC website. A quick walk through. The stop button we just mentioned is pin 7. The forward and reverse, those are the proximity sensors, are on 2 and 3, and then the analogs are 1 and 2. We have a number of states, which you'll see here below. This is the same code we talked about in the simple version. We define a siren, and then we define a motor on it, started as at the stopped position. And then all we're doing is we're using the forward state to hold the digital read of the forward button. So basically that is determining, the forward button is the proximity sensor, and it's determining if that's high or low. And we do that once in the setup because what I want to do is establish one set of values for everything, but then I don't want to reread everything down below. I'm only going to reread it under certain conditions. So we do have to reread the buttons that you can't avoid as you're looping through the code. And what you do is if the forward state is low, and that would mean that the proximity button is triggered, then it defines the current state as 1. And if the other switch is pulled low or triggered, then the current state is 2. And if the stop button is triggered, the current state is 0. And we immediately stop the motor because we want that to happen with no delay. Otherwise, after you have stored these states, you actually go through and say, okay, if the current state is 0, well, we know that's stopped. So you stop the motor. Actually, already should have been stopped with this up above, but nevertheless, it's good to have. We also delay for 500 milliseconds as a sort of debounce. If up above it saw, hey, I'm the Arduino and I see that the forward state switch is low, so I've set the current state as to 1. Here, if you say, here we're saying, okay, that state is equal to 1, so let's do this. Let's do the motor at the forward speed. And when it's moving forward, I can adjust that potentiometer, and change the speed. So how do you do that? Well, forward speed is an analog read of the forward speed pin. That's that analog 1 or 2, whichever one is for forward. And then what you do is you map it, and we want to say, okay, well, we know that the potentiometer can range from 0 to 123 or 1023, but we only want that range to be 1 to 127. But we actually want it to be inverted so that when you rotate the potentiometer clockwise, it increases the speed. That's what feels natural. You do the exact same for the other state. If the other switch is triggered, then you say, okay, let's move the motor at the reverse speed. What is the reverse speed? Well, let's read that potentiometer. and we're going to map that potentiometer range, which is as wide as 0 to 1023, but we only want to control it from, scale it down rather, from -1 to -127. And again, I have it going this order, -127 to -1, so that as you rotate the potentiometer clockwise, you increase the speed of the motor. So that's all the code there is, folks. Let's upload this and take a look how she runs. Actually, before we put a little hammer on here, I thought I'd show these proximity sensors just so you can see they're non-contact. So if I hover this, it's actually an old Harley-Davidson piston, at least that's what I was told it was. My grandfather gave it to me as a punch, works great. And this will have an LED, a red LED that'll light up when it's triggered, like so. And then same thing over here. Boom. And you can see our motors working, switching the directions, like so. I'll use the potentiometers to increase the speed a little bit. And the cool thing is these also work with aluminum. A little shorter sensing range though. Just like so. Hit our stop button here. Put our hammer back on. Now my original hope was you could run this thing pretty quickly and have it reverse without touching these. It doesn't look like that's actually going to be possible when I was experimenting. And that has to do with the Arduino processor rate. Although, you know, I was thinking, and this is something I'm going to do more experimenting with, is if you increase the baud rate of the serial protocol that we're using, maybe I can get a little bit better reversing and performance out of it. So again, if you're interested in this type of stuff, whether it's motors and Arduinos and machining and prototyping and fabrication, definitely subscribe. I'll have more of this stuff to come. And again, this is just the framework, again, setting this stuff up because I've got one project in mind that I'm going to be putting this into and doing a video series on it. So looking forward to that. Let's go ahead here, just turn them down a little bit so we're not starting at full speed or anything. And I will just start it by tripping one of the sensors. So if I trip this one, it should go down to this one first. Perfect. Now this is slow enough, and I'll zoom in a second, that they should not contact because it's able to reverse in enough time to prevent that. Okay, so let's turn up the speed a little bit. So you can see if they're not hitting, it's darn, yeah, they're hitting. It's darn close, but it's not stressing. You'd hear or see, and we'll slow this down slow-mo. It'll be easier to actually see when I'm in production here in Final Cut. A little more speed. And that's bending that bar just a hair. Okay, that's basically it. Let's just, before we wrap up here, let's throw a little bit of weight on the end of that hammer and see how she does. Had a piece of lead, pure lead, about 5 pounds, sitting around, had a hole through it, so hard to argue with that. Just about as dense as you can get for the size. Now, 5 pounds isn't bad at all, and you're out here maybe 6 inches, so that would be the equivalent of something like 30 inch-pounds. And this motor's got way more power than that. But nevertheless, this is a pretty good amount of power, and it's more than what you normally see on a lot of the Arduino level stuff. So hopefully this will sort of prove the point of how good these controllers are. So we'll start off slow, not that slow. Okay, so you get the point there, no problem at all. increase the speed a little. And just for kicks, you know, you can start it, stop it, boom, anywhere, no problem at all. Restart. All day long. And you can go fast one way and slow the other way. We'll speed up the other way even a little more and see. So, hope you've enjoyed that Wednesday widget. I love these motors. Lots of people ask about servos or steppers, and those are great as well. But I think sometimes folks don't understand is you can control a DC gear motor or brush motor like this very accurately, and there's so much more you can do with these. You know, one thing that immediately comes to mind is you can put an encoder on this and turn it into a sort of synthetic device, stepper or servo, where you're able to control location and positional accuracy and so forth. So much more to come on this. If you guys are interested in this type of stuff, please subscribe to my channel. More Arduino prototyping, fabrication, machining, all that good stuff. You guys know I appreciate the thumbs up, the likes, the comments, the shares. With that, I will see you guys next Wednesday, if not sooner. Take care.